I mentioned that we were going to just do demos that will help you. So you can refer back to these videos and whatnot. And you can ask questions as I go and whatnot. So a couple quick updates. Apparently drop-in tutoring is not available this semester for this course. But you do have 3 TAs and myself. So feel free to use our office hours, contact us, make an appointment, whatever. Homework 01 will be assigned probably within the next week. It's very similar to what I've always given as the homework assignment for this course, but it's to start getting you familiar with GitHub and Git if you don't know it already. So those of you that know it, then good for you. You'll probably learn something how to push and do some things differently maybe, but if not, then that's fine. Lab this week, we're just gonna practice, like I said. So I'll give you a prompt. To make it less boring for those students that want more of a challenge or do their own thing, I'm going to have, from now on, starting this week in lab, you're going to have 2 choices between labs. You can either follow my prompt and my guide to help you learn, or I will give you a short number of commands / topics you need to cover, and you can make up your own assignment and do your own thing. And as long as you tell me what you do, how you did it, and a short little summary at the end and submit that for your lab, you're good. So I'll let you pick what you want to do. You just have to follow a certain couple rule sets. So does that sound good? Maybe a little bit less mundane and monotonous? So you get to do whatever the heck you want, really. So you can pick and choose. So yeah, you don't have to do my boring labs. But if you want to do my labs, then that's fine. There's nothing against it. Okay. So, quick joke I found out this weekend, because I was learning about some VI and stuff myself. If you search VI on Google, it asks, did you mean Emacs? Emacs is a different text editor. And for a long time, it's been argued in the history of the text editor, which one's better. There's been arguments and stuff all the time when people are like, I use Emacs. No, I use VI, and they have huge arguments on Reddit and whatnot. Conversely, if you do Emacs, it says, did you mean VI? So Google and people have a sense of humor. It's stupid. Also, if you haven't played the boba game yet, it's pretty fun. If you just click on the icon, it's pretty fun. It's actually made me rage quit a couple times. So, because I sit here trying to get all things stuff. Yeah, it's pretty fun. If you want to try that. Okay, so back on topic. All right, so we've learned all this stuff. This is just for your sake, if you want to use it as like a review sheet. We've learned all these things. Now let me do a demo of them, show you how you can maybe use them in the real world and whatnot. So we learned Vim. Just a couple quick review about Vim. Different modes. So many different modes. You have normal mode, visual mode, insert mode. Those are the primary 3. There might be others, I'm not sure, but those are the 3 that I usually use. Then you have the default as normal mode. Editing is insert mode. And then visual, which we haven't learned, is like selecting stuff with your cursor. So you know when you click and drag and highlight things, that's what visual does. So we'll learn it today. I'll show you how to use it. So if you don't like this representation, which I don't personally, you can use this one to kind of visualize what's going on here. So everything starts from this normal mode right here. And then you have different modes. So if you press I, you go to insert mode. And you can do these things. You can move your cursor up, down, left, and edit. You hit escape, it goes back to normal mode. Okay, well in normal mode, you can do all these what are called commands, Vim commands. And most of them are preceded with a colon. But these 2 down here, YY and DD, don't, which we'll see in a second why. With visual. These are kind of like visual related commands, but you can use them in normal mode. But I'll show you those in a second. And then you have visual. So what you do with visual is you move your cursor wherever you want in the document, like you would normally do with clicking and dragging. You move your cursor to that point, press V on the keyboard, and then you move your cursor again, and you'll notice it starts highlighting. Like I said, I'll show you this in a second. And then you press Y to copy, P to paste, and X to cut. So why is it Y to copy? People are like, oh, what the heck? It stands for yank. Why they chose to do this, I don't know. So yeah, Y stands for yank. Okay, so last week we learned we can do vim file names, or you can do similarly VI file names. So vim and VI are two different programs sometimes. If you're on a really old server and you do VI, it doesn't always look like vim. Vim literally stands for VI improved. So they're sometimes two different things. Most of the time they're exactly the same thing. But yeah. Okay, so that's vim. That's enough of that boring stuff. So let's do vimrc. So I've shown you that you can do like your little vimrc customization, and hopefully the network will cooperate with me. So you're going to get an SSH tutorial too. So SSH-P222 PSC at 129.252.130.196. And somebody is calling me, and I don't know why. All right, who got my phone number in here calling me during class? No. Okay, that was a joke. All right, so it asks you if you want to actually connect. You type yes, you press enter, and then it asks you for your password. So do my password, press enter. Maybe my fingers will work. There we go. And then press 1, and then get my phone out, press approve. Now I'm in the Linux labs, and hopefully this will work pretty well. And I'm going to zoom in a bit so we can see. Okay, so your vimrc lies inside of your home directory. So in your home directory, this tilde directory, tilde home, same thing. Anytime I'll use them interchangeably. If you do ls-l and a, maybe, we'll learn about this in a week or two, al, whatever. It lists all the files in the directories in this directory. So it even includes these dot files that start with a dot. Again, when you have a dot at the beginning of a file name or a directory name, it just hides it. It's there, it's just hidden. So if I do ls like normal, you just see those. Those don't have dots in front of them. If you do ls-a, it shows everything with a dot in front of it, then you get all the hidden files in directories too. And then if you do ls-al, well, it's the same thing as ls-a, but now you have a longer format, which it listed in. So this has permissions, properties, timestamps of when it was last updated, whatnot. So we'll learn more about this. You can start using them if you wish. All right. So in this case, we have this .vim folder, and this has the Vim program and other things in it, configurations, whatnot. But what we want to do is create .vimrc. So if I do vim.vimrc, so this is just a hidden file. It's also the configuration file. So Vim, the actual like text editor program, is looking inside your home directory for this customization like file, this configuration file. So if you do vim.vimrc, then it'll open up a file called .vimrc. And in here, you can actually type your like settings. So syntax on, it turns on syntax highlighting. So if you like the pretty colors of text and everything, it's in syntax, it turns that on. If you do set number, that turns on line numbering. You can do a ton of different ones. Like in my GitHub, I have a longer vimrc. So we're just going to do those two. So if I write it and save, so write and quit, and then I open it up again, you'll notice now I have line numbers. So that's what this set number does. Now, if we were doing a coding, if we were coding some kind of file like a Java file or whatnot, .java, it would actually syntax highlight it. But there's a ton of different configurations. So I'll actually go to my GitHub real quick, and I'll show you which ones you have available to you. Files. So I have this GitHub repo. I have it linked on the Dropbox if you want a reference to it. It has a bunch of helpful stuff in it. If you go here and then go to my etc directory, so for configurations, and then you go to vimrc. Here's a lot of different settings I have. Let's see, can I zoom? Yeah. So there's a ton of different settings you can put. I don't ever remember them all. I write my single vimrc, then I copy it everywhere I go. So there's a ton of different ones. There's auto indent. So if you press enter and you're indented, it will follow that indent. You've got smart case and ignore case. So when you're like doing searching for keywords and whatnot, like we learned last week, it doesn't actually rely on it being uppercase or lowercase when you search. Ruler, you've got tons of different options. So ruler just shows how many characters and words over you are. So if you're writing a file or whatnot and want to keep everything aligned to 80 characters horizontally, then it shows you on the bottom that there's how many characters you've typed so far. Set number, like we had, sets the line numbers. You've got tab width. So if you want to change your tabs to spaces instead of a tab character, then you can do that. You can do syntax highlighting, like I said. And then if you really want to have some fun, you can change the color. So this one's Elf Lord. This is my favorite one, but they've got a ton of different themes in it. And if you look up the Vim themes, it'll tell you which ones you can use. There's, I think, certain color themes. There's a ton of them. So if I just pick on this one, then you can see, you can scroll through here and find the one that you like. You could also maybe just install some too if it's your computer. But yeah. So yeah, that's how you customize Vim. All you have to do is just edit your vimrc file. Or it starts with a dot. So vim.vimrc. Edit it, put your configuration here. You can use mine if you want to. You don't have to. But yeah, you can customize it, make it look your text editor look like what you want it to be. So, okay, so that's what now? Auto commands. So you can set up macros. So these right here help you with. I set these up, and to be honest, I looked them up on Stack Overflow. If the file type is a C, C++, .java, .python, etc., then it formats it a certain different way. So you can set it up to where it detects what type of file it is and then has a different indent type. That's specifically what I wanted it for. Because we'll learn later in the semester with makefiles. Makefiles don't like spaces instead of tab characters. If you put a space character, it'll actually yell at you. So it won't work. So that's why I have this. So yeah. All right, so that's vimrc. You can customize it however you want. You don't have to do anything with it if you don't want to, but it's definitely makes your life a little bit easier. So yeah, this is the ruler down here, by the way. This ruler shows one character, and if I move my cursor, it shows line number and how many characters I am across. So it's helpful. Okay, so that's your vimrc. Before we do that, the next part, there's some Vim commands that I alluded to in the slides that I haven't showed you yet. So here we are. So I'm just going to exit out of this, and I'm going to go to just some script, and I'm going to show you how to use it. So I have that same exact GitHub repo that I have on GitHub is also cloned locally into the Linux labs too. So I can go in here and actually edit it and then push my changes. This is a very out-of-date version though. So .bash-rc. Or no, just bash-rc. Bash-rc custom. Oh, and of course it doesn't have anything in it. Trying just to find a file. Maybe I can do this one. Yeah, bilinux.sh. Maybe not. Okay, so I guess I'm just going to clone a new version of it. So rm-rf. So this is how you delete a directory. And do it by force. So -r stands for recursive. And then adding f to it does it by force. So this is the very dangerous command. But if you know what you're doing, it's fine. So .files. So the nice thing about Git is if you want to clone your repo, you just do git clone, and you'll do it a different way for your homework. github.com/username/.files.git. So you'll do something very similar to this. Spelled it wrong. Do something very similar. So it just downloaded all my stuff from GitHub. And now I can go in and get the new version. Bin, and then VI. So I have a bunch of different scripts here. So I mentioned that really long 300-line Arch script. Here it is. And there's a couple things here. So if you want to do, like, instead of modifying your vimrc, you can actually just do these commands that you did in your vimrc inside of Vim. So if you want to turn off numbering, for example, you can do while you're in normal mode. So you do colon and then no num, or no num, same thing. Or no, it's no new, no new. What? Oh, set no num. No. Okay, now set no new, maybe. There we go. It's one of those. So yeah. So if you do set no new, then it turns off numbering. If you do set new or set number, same thing, it turns on your numbering. So you can turn it off, turn it on inside the Vim editor without touching your vimrc. So again, set no new or set no number if you want to. Same thing. All right. Some of you notice that when you do patterns, so if I search for the word function in this file, it highlights function, but then how do you get rid of the highlighting? So somebody taught me this last week, or made me look it up so I could answer the question. So you see function is actually highlighted, but I can't get rid of it. So in order to do that, you do another command in Vim, and you say no H, or no highlight, and it gets rid of your highlighting. You can do all kinds of things. Say you're in the middle of a file and you want to jump to the top really quickly. You can do colon and then the line number, like $:1. Press enter, it takes you to the first line. If you don't believe me, set number. So my cursor automatically went to line 1. If I want to go to the end of it, you do just $:, and that goes to the end of the file. So you can go up and down, left and right. You can enter these commands to go to a specific line number, whatnot. So if you're like debugging a program and you've got like 1,000 lines of code and you don't want to sit there and sift through all those 1,000 lines of code, in Vim you can actually, when the error log gives you error, line 15 has a syntax error, you can just do :15 and it will jump straight to that line without you having to sit there and scroll through it. So yeah. Okay, so let's learn a couple other things. So I mentioned YY and DD. So YY stands for yank yank, and it yanks an entire line. It copies an entire line. So if you do YY while you're in normal mode and then press P, then it pastes that single line over and over again, however many times you hit P. And we can keep going with that. You can also do DD, which is delete a whole line. So if I want to undo all that, I can do DD and just keep doing this until I delete all the lines that I want to. And eventually we'll get there. So yeah, if you do DD, it deletes a whole line. YY, it copies an entire line. P is for paste. Okay, so what if you have a piece of code you want to copy and paste? So that's where visual comes in. So remember, insert, you press I, you can start doing things, whatnot. But if you want to like copy and paste, you can do V. So you see now down here at the bottom it says visual, and you can just move your cursor and you see it's highlighting now and selecting text. So let's say I want to take these echo statements and copy and paste them. So now I've highlighted the text that I want to copy. I press Y, and that yanks. You can see it even at the bottom, it says yank. 7 lines yanked, and then you just press P and paste it, right? Alternatively, you can do cut. So if you go into visual, do your text selection again, and then you press X for cut, and then it cuts it, and then you can paste it. It's same thing, copy, cut, paste. They're all analogous to what you're used to with the mouse. So now you know how to use visual if you want to use it. You don't have to. You can still just do Control-Shift-V, Control-Shift-C if you want to and use your mouse. But yeah, if you want to use visual, there, now you can do it. All right. Any questions? Fun stuff? Right. So learning more about Vim, you're starting to appreciate it maybe a little bit more, I hope. Don't hurt its feelings. Okay. So yeah, you got different Vim modes, whatnot. All right. So we created file, we did vimrc. All right, so SSH servers versus clients. So this goes back to our little networking information. Whenever you have a program that needs to connect somewhere else, the program that you're using is called the client. The client is usually on your computer. So it's just a program that allows you to use something that's remotely accessible. Now, the thing that allows you to access those things remotely is called the server. So it serves the information or whatnot you need, or allows you to access, the clients to access things. So you got servers and clients. So what we were doing with SSH is all the Linux labs have SSH servers on them. And all your computers, whether they're Mac, Windows, Linux, whatnot, have clients. So when you do the SSH-P, you're using the SSH client. Now, and then that accesses what's on the Linux labs called the server. So that's boring. So let's like actually look into this a little bit. All right, so there's an SSH config, and there's 2 of them. So there's a client config, so that's for you to make your life easier. And then there's a server config if you're wanting to set up your own computer to have remote access. So if you're at home and you have your desktop and you might have Linux or whatever, you can install SSH server and then remote into it that way. Again, I'm grossly oversimplifying some of this stuff because there's a lot more steps involved, but it is possible. I have remote access to my office computer. Okay, so the client SSH config is in another hidden directory. So ls-a, and it's called .ssh right here. So this is the directory that has your SSH configuration in it for your client. So cd.ssh. And in here, this is where you store your SSH information, keys, whatnot, if you want to. And then you have a file named config, right? And inside of here, hopefully this doesn't have anything sensitive. Cool, it doesn't. So you have different configurations. So if you want to make your life easier in the Linux labs when you want to remote in, you can actually edit this file and add your own configuration. So in this case, you do the host, you do the keyword host to tell it, hey, this is the host, and then you do the IP address of that Linux lab computer that you like, that's your favorite. 129.252.130.196, right? And you can just type that in. And maybe you're a good program, you put documentation and you say this is Linux Labs, right? And then your username, user, and then my username is PSC. And then maybe you want your port 222, should be familiar. And that should be it. So remember that whole long command that we did, ssh-p or psc at 129.252. Instead of doing that every single time, you can modify this and put this kind of information in with your information and your favorite IP address, and then save and quit it. And you can do SSH, and then your username at, and hit tab a couple times, and it will actually try to auto-complete it, and see there's an option right there. And then you can do 129, and then just hit tab, and it auto-completes it for you. And then you press enter. You don't actually have to put -p because it implies it. Since you've edited the file, it looks in that file to actually check and see if that port, what the configuration for that host or IP address is. So if we do this, then we get that message that we're familiar with. So yeah, you can edit your configuration file, your SSH config file, to make your life easier. And you'll actually do this in your first homework. And you'll do something very similar to this one right here. So you'll add this. So this is for GitHub. And this is for adding public and private keys to your GitHub, which we'll go over in a second as well. Okay, so that's your SSH client config. So what about if you want to edit the server config? Say you want to set up SSH at home. Also, if I do cdd, that's an alias. It's cd ... We'll learn about aliases soon. That also makes your life easier. So if you want to edit your server, SSH server, you go to etc/ssh/sshd config. This is a file, and I'm just read-only it. I can't modify it anyway because I don't have access to it. But if I look at this, then this is a big lot of stuff, mumbo jumbo. But there's your port, 222. Familiar, right? So this is where you can change this 222 on your computers to something else, and it's actually good practice to change it from 222 or 22 to something else completely different, like 215 or something maybe. And you can change it to whatever you want to, or you can leave it the same, 22, which is the default. So instead of doing -p 222, you can do whatever -p 215, whatever you want it to be. This is where you change that. Then you have a bunch of different other things. So a lot of these are things that the IT manager set up. But yeah, you can specify how to authenticate, all that stuff. So this is the server config. This is what's checking your credentials and making sure everything is configured correctly and whatnot. So it's pretty long. We're not going to go over it. But yeah. So, all right. So in your first homework, you'll most likely need to use what's called public-private cryptography, or SSH keys. So what public and private keys are is, think of, you have some kind of message you want to send to somebody, right? And you don't want that message to be readable by everyone in the world, right? So what you do is encrypt it, right? But then you also want them to be able to encrypt their messages and send to you, and only you read it. So what you have in public-private key, the reason it's called public-private key, is you have two keys. You have one key that you can share with the entire world, and it doesn't matter. And then you have a private key that's like a secret password, or secret key. You never want to share it. So in your first homework, you're going to create this like private or public-private key pair, and you can give the public key to anyone, GitHub, your friend, your neighbor, girlfriend, boyfriend, whatever. You can give it to anyone. It doesn't matter with your public key, but if you share your private key, I'm just going to go ahead and warn you now, if you put your public or your private key on GitHub, you're getting a 0, at least at first. I'll let you fix the mistake, but the private key is really, you cannot share it. So take this as your warning. Do not share your private key. But yeah, I'll show you how to do it real quick. So cd.ssh. This is just, again, go into the SSH directory because we're creating a SSH key. And we're going to create a new key called maybe 215, or just a directory, a new directory. So now we have this new directory. We're going to go into it, cd215. And now we're going to do our keys. So ssh-keygen. And like I said, this might seem overwhelming, but it's going to be in the first homework. So you'll actually have these commands and everything at your disposal. You do ssh-keygen-t ed25519-a. Any number, really. I usually like it to be over 100, so maybe 130 or 122. I just typed it. And then -f. ID ed25519, and I need to put a /. Okay. And so then it asks you for this passphrase. Yeah.
What is the 25519? Why are you?
So this is a cryptographic algorithm. Specifically, it's an elliptic curve algorithm. So if you're familiar with cryptography, you basically have this special curve called an elliptic curve, and there's a way of generating a key out of it, a public-private key pair, and this is mainly just for security. It's for encrypting things, decrypting things, and whatnot. So there's tons of different public-private key algorithms. There's RSA. There's other ones that I can't think of at the moment, but yeah, there's quite a few of them.
So you're specifying the algorithm that is
yeah.
used.
So you could put RSA or RSA 2048. You could put RSA 4096, whatever algorithm you want to use. But that's not too important. But anyway, so on the Linux labs, you should set a passphrase. So when you generate these keys, they're stored as plain text. So anybody could read them if they had access to your profile on accident. If you accidentally give them access, they can accidentally get access to them. So you should put a passphrase. So I'm just going to put one in here. And again, you see it doesn't type, but it is entering things. And then it generates this key, which also, if you have any plans of deleting or using this key, I'm deleting it after class. So no one can have my key. So yeah, now it generates this public-private key. So now you get these two different files named like this. If you used RSA or some other algorithm, it would say RSA instead of ED25519. Okay, so it's pretty clear which one's the public key, right? It's got .pub on the end. So that's the one you can share with anyone. And in fact, I can share it with all of you right now. Oh, that's the private key. So you don't share that. Anyway, it's being deleted in a second. So you don't share that, but you can do cat id.ed.pub this time, and that's what you can share. So this is fine to share. This is completely fine to give to anyone you want to. And what this key does is that allows you to encrypt your messages, right? You can take messages, encrypt your messages with this key. I know it looks like a bunch of gibberish, but you take the algorithm, you encrypt stuff, and it spits out a new message that looks like nonsense. And then the only way you can decrypt it or unlock it is using the private key. So this private key that I told you specifically not to share, it even says private key at the top and below, it decrypts the message, and it's the only way of decrypting the message. So when you hear of quantum computers and like cryptography and privacy is going to be broken, this is why. Because this private key is generated by, like, you can't crack it unless you have it. Not at least with conventional computers. So it's very hard to get this or generate this. Yeah.
Aren't quantum computers still a while away from even being able to...
We have one at the university.
Really?
Yeah. we have a quantum computing with, we work with IBM. I think IBM's providing it. And we have access to it.
Yeah, but still, wouldn't it take a while for it to crack the...
Not necessarily. I mean, I haven't done. That's not my research area, so you might be right. But yeah,
So I was taking cybersecurity last semester, and they were talking about how it's still in their early phase.
Yeah, it's still in its early phase. Like, quantum computing is definitely still early, but there's a lot of worry that it can do these things. And as soon as it does it, then we need to find new cryptography algorithms. So
They're already developing cryptography.
yeah. Oh yeah, there's quantum cryptography coming out. So, but anyway, so you get this private key. This is the only thing that can decrypt that message. So you encrypt it with your public key, and then in order to, the reason you don't share this, because it can unlock it. Only this private key can unlock that message and actually make it make sense. So, does that make sense? I know it's a little bit kind of a fumbling thing, but yeah. So in your homework, you're going to create this public-private key. You're going to upload your public key to GitHub, so GitHub has access to it. And that means GitHub can send you messages, but only you can read them because you only have the private key. So yeah. All right, so that was the spoilers. A couple other things. SCP. So I actually created a VM. We still got 7 minutes. I'm just going to go over it. If you have to go somewhere far, you can feel free to leave. But if you're a Windows user, it's okay. I'll switch you to Linux by the end of the semester, I promise. Anyway, so if you're trying to access the Linux labs, you do PowerShell, you open it, and you can do that SSH command, just like normal, and it logs you in. But the number one mistake I have people do is they do this SSH thing, and then they try to SCP from their remoted in session. So I'm remoting in to the Linux labs in Windows. And when I'm in here, now I'm in the Linux labs, right? And that whole conversation we had a week or two ago about public and private IP addresses, people will start doing this, SCP-P222, some kind of file from the Linux labs, so your source file, and then destination, right? What's wrong with this? What's wrong with doing it inside the Linux labs? So the terminal's remoted in. What's wrong with me trying to copy something from the Linux labs? Yeah.
Someone see what you're trying to do?
No, not quite. It's still encrypted. Yeah.
SCP is trying to pull a file from the destination, right? So you're
Yeah.
trying to pull a file from your computer
Yeah.
back onto the Linux lab.
Yeah, and it doesn't know where it is. So if you're trying to do SCP from the Linux labs, your computer's got a private IP somewhere, and the Linux labs have no clue where your computer is. It doesn't. You probably don't even have any clue to how to get stuff from your computer. So to do SCP, you have to do it from your computer. So the way you fix this is you type exit, and now you're in PowerShell again. So you see it says PS for PowerShell and whatnot. So in order to actually secure copy something from the Linux labs to your computer, or vice versa, you have to use PowerShell in your laptop or your desktop. So you do, from PowerShell, you do SCP-P222, and then whatever file, if you want to copy it from your Linux, or to the Linux labs. Let's see what I have in here. Let me just create another let's create a file. Touch. Does touch exist? Yes, it does. Touch file.txt. Okay, maybe not. Maybe .ssh. There we go. So you'll notice that this is very similar to Linux. It's got its own way of doing things, but it's very similar. Okay, so here. SCP-P222 known hosts. And then, so that's the source file that I want to transfer to the Linux labs. Then you do PSC at 129.252.130.196. And the other thing you have to do is you have to give it a destination. So that copied thing, that's lying. It's lying. So I'm going to do it tilde to my home directory. So see, it gives me the prompt for the Linux labs. And then it's going to immediately push it to my Git Duo. And now it's copied. So now if I open up this terminal that's in the Linux labs on my MacBook and go back to home, there's my known hosts. So I just copied that file from Windows to the Linux labs using PowerShell. And then I could do the same thing vice versa. So if I do move known host to new file test, something like that, then just keep in mind that this new file test is inside your home directory. So inside of Windows, we can copy it. So SCP-P222. Now we're taking something from the Linux labs to our computer. So PSC at 129.252.130.196, colon, then the file that you want to copy from it, / new file test, and then dot. It asks for your password again, send you Duo. And then if we do ls in PowerShell, there's the new file test file. So we just copied something to the Linux labs, changed it on the Linux labs, then copied it back, all using PowerShell. So the important part is just make sure you're not doing SEP while you're remoted into the labs. You have to do it on your computer's terminal.